Okay, let's start our new part of lesson 2 or part 2 of trigonometry, and uh, we're gonna learn about angles of elevation and depression. So that's how they look. So that's a 90 degree. Okay, the green line is called the line of horizontal, and this line is also called the line of horizontal because it's horizontal, and the dashed line is called the line of sight. So if you're standing up there and this is the line of horizontal and you're looking down, so this is called the angle of depression. And if you're standing down here and you're looking up, so you are looking up, okay, looking up at this angle is called the angle of elevation. Here's another example. Okay, that's a 90 degree, by the way, but here's another example. Okay, so that's a triangle, right angle triangle, and that's the horizontal line, that's the angle of depression, and that's the angle of elevation. Okay, so we have a simple rule for that, which is x equals y equals arc tan opposite over the adjacent. Okay, we're gonna use this rule to find y or x because they're both equal to each other. Okay, so arctan, as we studied in the previous video, which is part 1 of trigonometry or trigonometry 101, that arctan is also called tan inverse or tan to the power of -1. Okay, so that's the opposite and that's the adjacent. So you will always be given the height and the horizontal distance. This is also known as rise and this is known as run. Okay, sometimes they are used to find gradient, but over here we're going to use them to find tan, and tan is also known as gradient. Okay, so don't get confused. Right here we're going to do it as I'm writing it, so don't get confused. So this is the rule that we're going to follow, and maybe sometime later, third week, fourth week, we're gonna be solving past papers on trigonometry, and I hope to do this very sooner, but it depends on what I'm gonna do. Okay, now let's do an example. A control tower operator is looking at a plane taking off. If he can see the plane at an angle of elevation, that means he's looking up. So he's standing down and the plane is high up in the sky and he's looking up at an angle of 15 degrees. And the plane is 350 meters above the control tower. So as I said, the plane is up and its height from the tower is 350 meters. What is the horizontal distance from the control tower to the plane? Okay, so if you can imagine it, that's how it looks. So that's the control tower, that's the plane, and the difference in height between the control tower and the plane is 315 meters, and the horizontal distance that we want to find is x, and he given us the angle, which is 15 degrees of elevation. If he were to give us this angle, he would say the plane is looking down at the tower. That means this 15 degrees is called the angle of depression. Okay, now let's try and solve it. So first of all, we're going to tan angle opposite over adjacent, and I managed it here to write it in a different way so your eyes get used to the different forms that it can come in. The rule I'm talking about the rule. Okay, so tan angle equals opposite with the adjacent, and if you don't know what tan angle is, you should go to the part 1 of the video. It's gonna be explained briefly in that, and you'll have a solved example of that also. Okay, now let's substitute. So tan, which is angle is 15, so 15 equals 350 over x, which is the adjacent. So that's the angle, that's the opposite side, and over here between the angle and the 90 degrees is called adjacent, and that's the hypotenuse. Okay, so let's find x. So we write it down on the calculator. It should look something like that, and x is equal to 1306.2 rounded off to 2. Okay, don't forget to write meters. Now he may also ask you to find the hypotenuse, or the shortest distance between the tower and the plane, which is this one, and we're gonna use the Pythagoras theorem, and we have talked about that briefly on our first video. Okay, now sine rule and cosine rule. As we studied about sine and cosine. However, sine and cosine were for right angle triangle. Okay, but over here sine and cosine rules, so there is the word rule in it because it's a rule for any type of triangle, not just right angle triangle. Okay, so it's not a rule that you need one of these sides to be right angle. Okay, so what does the rule say? Okay, so a over sine a equals b over sine b equals c over sine c. And here's the rule. So you can use this to find either sides or angle, but it's better if you're using sides, you should put sides on the top and angles at the bottom. Okay, so the numerator is the sides and the denominator is the angles. Okay, or you can use, for finding angles, you can use sine a over a, sine b over b, sine c over c. So if you're finding angles, it's better to put the angles on the top and the sides on the bottom. Okay, now same goes for the sine rule. So sine rule says a squared equals b squared plus c squared minus 2 bc, which is bc over here, cosine a of this one. Okay, so how to memorize that? So it's easy to memorize sine rule, but it's kind of hard to memorize cosine. Now you're wrong, my dear. Let's do it in an easy way so you can memorize it. Okay, so if you want to find this side, you're gonna say this side squared equals c squared plus b squared minus 2cb cosine a. So if you're talking about this side, you're gonna choose the side is opposite to it and the angle between them. Okay, so for example, if you want to find c, you're gonna say c squared equals a squared plus b squared minus 2ab cosine c. Okay, now you can use this rule to find angles and to find angles and also to find sides. However, it's best to use this rule to find sides, and cosine a also can equal b squared plus c squared minus a squared over 2bc for finding angles. Okay, so we just said that the cosine, we make it as a subject. So what I say is that this minus 2bc cosine a goes up to the other side and a comes to this side. Okay, so it becomes a squared and you're gonna divide by 2bc. So the subject could be cosine a. Now when to use the sine rule and when to use cosine rule? Okay, so you use sine rule when you have two sides and one angle, or you have two angles and one side. Okay, now when to use cosine rule? So you use cosine rule when you have two sides and an angle, and that's the only case when you can use cosine rule. You must have two sides and one angle. Okay, so let's take an example on sine rule, and I think that will clarify some of the things that you can commonly get mistaken of. Okay, so an example. Over here he wants to find x, so we're gonna see first what knowns we have. We have two angles and a side, so the only case that we can use two angles and a side is sine rule. If we have two sides and an angle, we can use any of them, which is sine or cosine rule. However, you must have these two angles. So you have and so you must have one of the angles is in front of the um, the one of the angles is in front of the angle, one of the sides is in front of the angle. I'm so sorry about that, but yeah. So one of these sides is in front of the angles. Okay, so let's write down the rule. So we have uh, a over sine a equals b over sine b. Okay, now let's substitute. So now you can write even it's just some letters, so you can just write this is C and that is a capital C because angles are capital and sides are small. It's just important thing is that you know how to use the rule and how to substitute in it. So 7 over, so we're finding sides, so the sides are on top, so 7 over sine 60 and equals x over sine 80. Now we shift the sine 80 to the other side, cross multiplication, so x equal 7.96. okay, now round up the three significant figures. That's according to the IGCSE board. Okay, now here's another example on cosine, and how we know it's cosine because we have different sides and one angle, so two sides and an angle. Okay, now let's write down the cosine rule. So these are just letters, so letters can change, it's okay, but we must know how to use the rule. So if you're finding this one over here, so you're gonna say this is the r squared. Okay, now the equals this one squared, which is p, plus this one squared, which is q, minus 2 the multiplication of this one and this one, which is p and q, cosine this angle. Okay, now let's substitute. So now r squared, which is this one over here, the r is the pq. Okay, so 6.5 squared plus 7.4 squared minus 2 6 multiplied by 6.5 multiplied by 7.4 cosine 58. So r squared equals 46.03. Now what's our square root of both sides? You get 6.78. Easy enough, right? Yep, thank you.